Now, I'm going to talk through some of the graphs to do with this because this is a big deal. I'm just going to introduce the idea and then on Friday we'll go into a little more depth. Okay? So, we'll start from simple. I'll go as far as I can until the bell goes, and then that'll be the ideas that I'm going to build on Friday. Okay? So let's begin. Start simple. You're going to have to draw along with me. Okay? Y equals absolute value of x. This is as simple as it gets. Right? Now you can think about this two ways. Well, more than two ways, but at least two ways based on the definitions that I gave you the first time I talked about absolute value. Okay? So, example. First way you can think about it is just take the positive value. That was the most basic definition I gave you. Okay? So therefore you say, well, this is like y equals x, and I know what that looks like, but you just take the positive values, right? So here's y equals x. There you go, good old y equals x. Some of it is positive, so no problems. There you go. That part's all happy times. But on the left-hand side, I have a whole portion of the graph that is negative. Right? So instead, I make that part positive, right? So most people learn about absolute value graphs as, oh yes, the bouncy things, right? Because they come down to the axis and then they literally bounce, okay? That's not that complicated, all right? Let's think about a couple of variations on this. Let's think about, first let's modify it within the absolute value sign. So if I said, well, how would this thing be different? Okay, so we've looked at this before briefly. Again, I'm going to go to this idea of thinking about, well, what does x minus 1 look like? Okay, and it's just like x but drop down, right? And then again, I think, well, I just want the positive parts, so this bit's good and this bit is not. Okay, now this is a really important point under absolute value graphs. I'm going to put this on both of them because what you've got is two branches that are behaving completely differently. They in fact have different equations, and we knew this based on our definition from before. The absolute value of x means two things at two different places. When x is negative, the absolute value of x is negative x. And when x is positive, it's just regular old x. Okay? And these two are the equations of my two branches, right? There's minus x, and there's x. Okay. Now, exactly the same way, and you don't need to keep on writing it out in this formal way, you can start to see it, right? Here's the unmodified part. What's the equation of the unmodified part? It's just x minus 1. Okay? The part that we've flipped, we've just slapped a minus sign on it, right? See? There, I've just slapped a minus sign on it. So the effect that that has is just turning it around, right? Because it'd be minus x plus 1, which is the same as 1 minus x. Okay? What happens if the modification, the shift, is outside of the absolute value? So if I go absolute value of x and then take away 1, okay? Well, I'm going to think about this thing, because I've got the absolute value of x right there, and then this minus 1, it just brings the whole thing down, the whole thing, okay? So you've got to be careful, because even though we say, oh yes, absolute value graphs, they bounce, and they always bounce at the axis. Well, they bounce at the axis if you've got an absolute value around the whole thing. Right? But here I have an absolute value, and then I take that, and then I bring it down. Right? So it's going to look like this. There you go. Okay? Because of course, if I actually substitute a value, like say 0 into this, it'll become y equals the absolute value of 0, which is still 0, and then you take away 1. So it's an absolute value graph, but it does have negative components to it. Okay? Now again, I can write out the equations of these two lines. It's going to match this for that part, right? But what's the equation of the left-hand branch?
1 minus x.
It's going to be the negative case of this, right? So it'll be minus x minus 1. That minus 1's outside the absolute value. It doesn't get flipped around. Can you see that? Okay. And you can verify it because you're like minus x, gradient's going down, and the intercept is negative 1. Thumbs up.